problem. So we are going to perform few problems based on inverse functions. So here the two in an advanced level. If a function f which is from a into b is 1 to 1 and as well as onto, then the inverse, that is f inverse which is from b into a, is also a function. But in order to exist the inverse of that function, that is from f which is from a into b, so it must be of 1 to 1 and as well as onto. So here we are going to perform examples under this, that is example number 1. So under this first example, let g be function defined by or defined from a into a, or in other words, so can be written as g is a function from a into a, where a equals to set consisting the elements, that is 1 2 3 4. So here this function is shown by the figure, that is set consisting the elements, that is 1 2 3 and as well as 4 in the first set, and 1 2 3 and 4 in the second set, that is from a to a. So here a is of 1 2 3 4, so here this is of a, first set consisting the elements 1 2 3 4, and the second set is also of a consisting 1 2 3 4. But the function g is given by means of the relations 1 to 3, 2 to 1, 4 to 2 and 3 to 4. So here we have to state whether function, that is g, has an inverse function or not. So here the function, that is g, so we have to state whether it is possess or has an inverse function or not. So here the solution starts now. So in our solution, so as per the figure, the function is given by means of g which is from a to a. It is defined by means of, so here g equals to the ordered pairs which we get by means of the figure, that is g. So it is from the ordered pairs are of 1 to 3, 2 to 1, 1 comma 3, 2 comma 1, and the next ordered pair will be of 3 comma 4 and then 4 comma 2 are the ordered pairs of this function, that is g. So here to be an 1 to 1 function, that is no two ordered pairs, no two first coordinates have the, no two first coordinates have the same image in B. So here 1, 2 and 3 and 4 are the different elements of first set. So here the image of 1 is of 3 and image of 2 is of 1 and image of 3 is of 4, image of 4 is of 2. So here no two elements of no two coordinates of the first set is having the same image in the set B. So therefore, so your function g, so your g is said to be 1-to-1 or otherwise called as injection. Since the image of 1 is of 3, but here the image of 2 is of 1, which is different from this 3. So image of 3 is of 4 and image of 4 is of 2, which is different from 4. So here no 2. So here coordinates of the first set, that is A, is having the same image in the set B. So therefore it is said to be called as 1-to-1 or in other words injection. So here to prove it as the onto, so here the function g is given by means of 1, 3, here 2, 1, then now 3, 4 and 4, 2. But here we have to prove f of a is equals to b. So here f of a, if f of a is equals to b, then f is said to be onto, or in other words surjection. So based upon this principle, so here let us find out, that is f of a. So here the elements of a are of 1, 2, 3 and 4 first coordinates, and elements of b are of 3, 1, 4 and 2. So here first of all let us find out f of 1, that is the image of 1 is of 3, and similarly f of 2 is of 1. So here the image of 3 is of 4, that is f of 3 is equals to 4. So here f of 4 is equals to 2. So here hence, or since f of a is equals to b, so here hence f, the given function, is said to be onto function. But here we got f is of 1-to-1 and as well as onto, so here therefore f is said to be called as a bijection. So here in the next logical step, so here since function, that is f is 1-to-1 and as well as onto, hence f is said to be bijection. So here since it is bijection, therefore the inverse exists. So here since function, that is f is a bijection, hence inverse of the function exists. So here now let us illustrate one more, that is the second illustration, that is example number 2. So example number 2 is of, let the function f is from R to R, R into R, be defined by f of x is equals to x square. Then we have to find out the value of f inverse of 25. Then now solution starts. So in our solution, so here as per problem, so here as per the problem or according to the problem, the function which is given to us is of f, which is from R to R and defined by f of x is equals to x square. In order to find out the inverse of f inverse of 25, so here the given function is of, that is f of x is equals to x square is the given function. I am going to assume here f of x as y, whereas in the next logical step, so here let y is equals to f of x, then that is equals to x square. So we have assumed y is equals to f of x equals to x square, that is instead of f of x I replaced by means of y. So here the next logical step will be of y is equals to, that is right hand side is of x square. I am going to interchange both LHS and RHS at a time. So here x square which is on the right hand side comes over to the left hand side, and y which is on the left hand side goes over to the right hand side. So here I got this logical step. So here by interchanging LHS and as well as RHS at a time, so therefore there won't be any sort of changes in their signs. So now the next logical step will be of, so that implies in order to find out the x value, the square must be removed. When we remove the square on one side, we have to find out the square root on the other hand, that is x is equals to square root of the right hand side, that is y. So here square, so it is of second degree, we will be getting two values, that is plus or minus y. Then now in order to find out, but we have to find out f inverse of 25. So now that implies, so x is equals to plus or minus root of, so here y must be replaced by means of 25, that is at y is equals to 25. Then now, so now that is equals to, or that implies plus or minus root of, but 25 can be written as, so 25 can be split as 5 into 5, or in other words 5 repeatedly multiplied twice, it can be written as 5 square. Then now instead 25 we can write it as 5 square. Then now while replacing under the square root 25 by means of 5 square, then the square and the square root will be gets cancelled. Then now the next logical step will be of plus or minus 5 is the value of this x. So in this manner, but x is equals to f inverse of y. So here, so that is equals to root of, this is nothing but f inverse of y. So here say here f inverse of y, which is nothing but x equals to plus or minus under root, we simplified as 25, we got the value as 5, but here x is nothing but the f inverse of y. So here f inverse of y, that is equals to plus or minus 5. So here therefore f inverse of, so here y is replaced by means of 25, so y f inverse of 25 is equals to plus or minus 5, or the solution set is of plus 5 comma minus 5.